Okay guys, so we're going to be talking about roots. These can be square roots, cube roots, fourth roots, lots of different ways we can talk about roots. So on the first problem here, we're just looking at page 126, number 1. It says to find the indicated real nth root of A. So this right here would be our root. So this is saying to take the cube root of negative 125. So what that means is we need some number such that when we multiply by itself or use it as a factor 3 times, we get negative 125. So I can rewrite negative 125 as negative 5 times negative 5 times negative 5, because those 3 numbers, negative 5 times negative 5 is 25 times negative 5 is negative 125. So because I have 3 negative 5s, it just comes out of the radical, and the answer is going to be just negative 5. Would be the answer there. The next one, we have the second root, so that just means the square root of negative 400. Is there any number that we can multiply by itself and get negative 400? No. If we do negative 20 times negative 20, we're going to get positive 400. So this actually has no real root. We could say the answer to that is 20i, but there's no real root, and it's asking us to find the real nth root. Okay? For number 3, we're asked to find the 6th root of 64. The 6th root of 64, I'm going to break 64 down. That goes down into 8 times 8. Well, 8 times 8 is 4 times 2. This is 4 times 2. So I know the 4 would be 2 times 2. There's another 2. This 4 is 2 times 2, and there's another 2. So as soon as we have 6 that match, the answer is going to be 2. But actually in this case, what if I had negative 2, negative 2, negative 2, negative 2, negative 2, negative 2? Would those numbers still multiply to give me positive 64? They would, wouldn't they? So the answer here is 2 or negative 2. Whereas in this one, it had to be negatives, because positive 5s would not multiply to be negative 125. So the answer, if they ask you to find the 6th root of 64, is 2 or negative 2. Okay, evaluating the expression without using a calculator. This is asking us to do 64 to the 1/2 power. So if we're doing that, then we are going to think of this as just the square root of 64. This number right here tells us the root. The number on the top of the exponent, that tells us the power. So we have the root is always going to be the number on the bottom of the rational exponent. The power is going to be the number on the top. And so therefore, what's the answer going to just be then? It's going to be 8, isn't it? Okay, when we do the next problem, so what's the root going to be here? With 3. And guys, the way you can remember this is 1/3. The root is on the bottom. Think of the roots of a tree. Those are on the ground, right? Power lines, where are they? Up high generally, right? When you go past power lines, they're up in the air. So that might help you to remember that the bottom tells you the root, so this is the cube root of negative 27 to the first power. First power really doesn't matter. What is the cube root of negative 27? What number times itself or used as a factor 3 times is going to give us negative 27? Negative 3, good. Okay, so this one, what's our root? So this is going to be the 5th root of 32, and then to the 7th power. The 5th root of 32, just guess a number. Tell me a number you think it might be. You guys think it might be 2? Somebody said 2. So what's 2 times 2? Times 2. Times 2. Times 2. That's going to be 32. So therefore, the 5th root of 32 is 2 to the 7th power. Well, I already knew that 2 to the 5th is 32, so that means I just need to multiply by 2 twice. So it's 32 times 2. Times 2 again. So this answer is 128. I also could even do this on my calculator, guys. I can go to my calculator and type in 32 raised to the 7/5. 32 raised to the 7/5, and it tells me that the answer is 128. Okay, introducing a negative exponent. When we have a negative exponent, it's going to take this base to the opposite place. So right now, this is in the numerator. So if I want to make this negative exponent a positive, I'm going to take the value to the bottom. And now it's going to become a positive exponent, just the same as it was back in Algebra 1. So this is going to tell us our root. This is going to tell us our power. So what is the square root of 49? 7. So we're going to have 1 over 7 to the third power. And 7 to the third is 343. And so that's going to be our answer there. Now, if I have a negative base, does that mean I take it to the denominator? No. This is just the 5th root of negative 32 and then cubed. So if it's the 5th root of negative 32, we know the answer has to be negative, right? Because the negative times negative, 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 negative is going to give us a negative. So guess the number. What do you think it might be? Okay, let's test it. So negative 2 times negative 2 would be 4, times negative 2 is negative 8, times 2 is negative 16, or positive 16, times negative 2 is going to be negative 32. So you're right. So the answer to the 5th root of negative 32 is negative 2, and then to the third is going to be negative 8. And we're just going to do one more in this section. We have a negative 2/3 as the exponent. Is this whole thing going to go to the bottom? Yes, because it's an exponent that's negative. So this is 1 over 1,000 to the positive 2/3 now. So now this number is going to tell us the root. So we have a 1 in the numerator. What's the cube root of 1,000? 10. And then square it, and what do you get? 100. So this is going to be 1 over 100. Remember, we can even check this on the calculator. 100 raised to the negative 2/3. And watch what happens. I get this answer. Oh, I put 100 instead of 1,000. It's like, what? That's not the right answer. Try again. 1,000, extra 0, raised to the negative 2/3. And I get this answer, and then I can just math frac that, and then I get 1 over the 100. Okay? All right, let's go to the next page now. This is some matching. Matching these expressions to the correct other expression. So look at this one. This is A. It's getting raised to the third. And what's the root? The root is not just 1, it's actually what? 2. So this is A to the 3/2. So that's going to be letter C. What about this one? Think about how we write this one. How do we write that one? Alicia, what do you think? Very good. Negative A to the 1/3 power. And so that's going to match up with letter D. So now you guys think about this one. Michaela, what do you think? Good. And so that's going to be letter B. And then we obviously know this has to be A, but let's think about why. Well, if it's A, the power we have is 1, the root we have is 3, it's on the bottom, so to bring it to the top, it would be a negative exponent. So A to the negative 1/3. Okay, and now solving. Let's go over here and do number 17. It says to find the real solutions of the equation. Round your answer to 2 decimal places when appropriate. And we'll do 16 first really quick. Just divide both sides by 6. We get x to the third equals negative 1. We're going to take the cube root of both sides. So what is the cube root of negative 1? Negative 1, right. On this one, we divide both sides by 2. Then we're left with just x plus 5 to the 4th equals 64. Now we want to take the 4th root of both sides. Because if I take the 4th root of x plus 5 to the 4th, I'm just going to get x plus 5. We don't want to waste our time multiplying that out. That's what I see people do, and that's such a huge waste of time, really. Because we can just solve it without multiplying it out. And so now here's the way you can type in the 4th root of 64. Type in the number 4, go to math, and you're going to see the xth root, which is number 5. So I'm going to go down to the xth root. So now this is saying the 4th root of 64. And I get this. Another way I could have written this is 64 to the 1/4 power. You see how that would be the same thing? So watch, I could have typed it in as 64 raised to the 1/4 power. Make sure you use parentheses around that fraction. And see how it's the same thing, no matter which way I put it in. So this is going to be, now the other thing too, guys, when I take the 4th root, just like when I take the square root in an equation, only if it's an equation, then what do I have to put in front of this? Plus or minus. So this is going to be plus or minus 2.83. And then I have to subtract 5. So I'm going to have 2.83 positive, and then minus 5. Gives me this answer. And then I also have to do negative 2.83 minus 5. And that's going to give me negative 7.83. And the reason I'm using these little squiggles right here is because I actually took the 4th root, and this is an approximation. Anytime we want to say is approximately equal to, if we've rounded, you really should use that kind of notation. All right, let's see if we can get through 2 more, 19 and 20. So on this one, we would have to subtract 100. We get negative 1/10, x to the 3rd equals negative 100. Caroline, what would we do next? How do I get rid of divided by 10? Yep, and I'm in fact going to multiply it by negative 10. Because then I can get all that to cancel out just to x to the 3rd. A negative times a negative is going to be a positive. Add on another 0. Take the cube root. And what is the cube root of 1,000, everyone? 10. And so that's going to be our answer. Last problem. The volume of a cube is 1728 cubic inches. What are the dimensions of the cube? Here's a cube. Not a great picture, but it'll do. This is x, this is x, this is x, right? The length, width, and height are all the same in a cube, okay? Otherwise, it would have been called a prism if all of those were not the same. How do we find the volume of a cube? What do we do? Yeah, it's going to be area of the base times the height. X times x times x is x to the 3rd. And so how would we now solve then to find the dimensions? Just take the what? Cube root. I can either go under math and find cube roots. That's probably the easiest way. Or I could even do it to the 1/3 power. And I get 12. Okay? Questions? Make sure you do the assignment on 5.1. You don't have an assignment sheet, but it is on Canvas if you don't have time to write it down.